Class, remembering again our first order in kinetics, which gave us the formula k equal to 2.03 upon t log n0 by n. Class, you have zero order and first order in your syllabus. So questions are often asked on first order in kinetics. So the expression was k equal to 2.03 upon t log n0 by n. What was n0 and what is n? N0 is the original amount, n amount at time t. At the time t, 2.30 is constant and k is your first order rate constant. Plus, this n0 by n has various parameters. Means we can put various things over here. What are those? Plus, n0 can be original concentration upon concentration at time t. N0 can be original weight upon weight at time t. N0 can be original pressure upon pressure at time t. So class, we can put all these parameters in first order kinetics, but the question is that, but the condition is that the reaction must follow first order kinetics. So class, now let us have a numerical over here. The numerical says a first order reaction has T half, that is half life of 30 minutes. Find the time required to reduce to 20% of original value, reduce by 20% of original value. Class, as we are solving here two numerical because statements are more or less same, but they have different meanings. Reduce to 20% means whatever was the amount, now whatever the amount is left is 20%. Reduced by 20% means the amount left is 80%. So please remember these two things. So class, let us solve first one. But before you start solving, you must find out the value of k from t half. So class, we know k equal to 0.693 upon t half. So 0.693, value of t half is 30. So we get here k equal to 0.693 upon t half. And class, since t half is given in minute, so unit becomes minute inverse. So now we'll put the value in first order kinetics. K equal to 2.03 upon t log n0 by n. That was my expression. The value of k is 0.693 upon 30 equals to 2.03 upon t log n0. Class, whenever the question is given in percentage, original always 100, k always 100, and condition was reduced to 20%, means what is left there? 20%. Now you can very well solve it. In our case second, k equal to 2.03 upon t log n0 by n. Again, k will be same, 0.693 upon 30 equals to 2.03 upon t log original amount, again 100, but reduced by 20% means whatever is left is your 80%. Let us solve it, class. Log 5 is 0.69. So I can write 0.693 upon 30 equals to 2.03 upon t multiplied by log 5, and log 5 is 0.69. So the next step, t goes up, 2.03 multiplied by 0.69, 30 also goes up, divided by 0.693. Similarly, in this case, k remains same, 0.693 divided by 30 equals to 2.03. T we are supposed to calculate. Then log 100. Okay, you can solve here. We get log 1.25. And class, value of log 1.25, 0.096. So I take t here, 2.03 multiplied by 0.096. Again 30 goes up, divided by 0.693. Just hold on, class, I give the value. That gives you 68.79 minutes. It was for 80% decomposition. That gives you 9.57 minutes. So class, this is the way you will be solving if numerical are given on percentage. Now class, we are going to take numerical on fractions. Same numerical, reduced to 1/4 of its original value, reduced by 1/4 of its original value. This was in fractions, so k की value remains same. Now I am rubbing whatever we have done. So class k is already 0.693 divided by 30 equals to 2.03 time we are supposed to calculate log. Class, if in percentage numerical original amount was 100, then in fraction numerical always take original amount as 1. So original amount as 1. Now question reads reduced to 1/4 means whatever is left 1/4. So I'll just put 1/4 here. In the next step it becomes 0.693 divided by 30 equals to 2.03 upon t log 4, and log 4 is your 0.62. So t will be equal to 2.03 into 0.62 multiplied by 30 divided by 0.693. In the second case class, reduced by 1/4 means 1/4 has gone and 3/4 has been left behind. So see, 0.693 by 30 equals 2.03 upon t log, okay, original again 1, and now reduced by 1/4 means 1/4 has gone. What is left? 3/4. In the next step it gives me 0.693 divided by 30 equals 2.03 upon t log 4/3. Let us do one step more. 0.693 by 30 equals to 2.03 upon t. Okay, 4/3 gives you 1.33, and the value of 1.33 equals to 0.12. Now class, we'll solve both the numericals. Okay, let us do 2.03 into 0.12 into 30 divided by 0.693. So the first one, that gives me 61.81 minutes. That gives me 11.96 minutes. So class, we have done 4 numericals, we have taken percentage terms also, and we have taken fraction term also. Class, now we are going to focus on pressure terms. Now again a new numerical based on pressure, and this numerical is from your NCERT. For first order rate kinetics, following data were obtained for the reaction. Reaction is twice N2O5, giving me 2NO2 plus O2, and this data has been given to us time 0 second. Total pressure, P total pressure in atium observed was 0.5, and after passage of 60 seconds, the total pressure observed was 0.6. So find K. Class, we know the value expression, for first order kinetics, K equal to 2.03 upon T log. Now I am changing the expression. Previously we used to work on N0 by Nt. Now it is P0 by Pt. What is P0? Original pressure. What is Pt? Pressure at time t. Class, whenever we are going to put values here, so either it should be pressure of reactants or it should be pressure of products. But with the data, what we find that 0 second, at 0 second the pressure was 0.5. It means the reaction has not started. So whatever the pressure has been given to me, it was due to N2O5 only, because at 0 second the reaction has not started, and if the reaction has not started, only N2O5 was present in the reaction vessel and the pressure observed was 0.5. So class, we know this value. The original pressure of N2O5 was 0.5. But we don't know what is the pressure of N2O5 after 60 seconds, because once the after 60 seconds is over, N2O5 has been dissociated to give us NO2 and O2. So the pressure observed was 0.6, and this 0.6 corresponds to all, because all are gases. So we know P0, but we don't know pressure at time t. So for that, we'll have to work on this reaction. See here. Class, we all know that volume remaining constant, very important. Pressure is directly proportional to number of moles. Let us take a room of capacity 22.4 liter. We know that if the room has capacity 22.4 liter, the gas, the air inside the room will be 1 mole, and the pressure will be corresponding to 1 atm. But let the volume remain same. Put 1 mole atm gas again in the 1 mole gas again in the room. So now there are 2 moles. So the pressure is definitely going to increase to 2. Put 1 mole more, the pressure will increase to 3 atm. So volume remaining constant, pressure is directly proportional to number of moles. Always remember. Now see. At t equals to 0, the pressure observed was here 0.5, and at that time they have 0 moles and 0 moles. Pressure directly proportional to number of moles. Either I can say atm or we can say number of moles. After dissociation, class, it has stoichiometry 2, it has 2, it has stoichiometry 1. So let x moles of O2 were present. So NO2 will be 2x. And what will be the concentration of moles of N2O5? 0.5 minus 2x. Very, very important calculation here. I repeat again. At t equals to 0, N2O5 was only present. So the pressure found in the vessel was of N2O5 only. So it was 0.5. And at the start of the reaction, product were 0, 0, 0. After dissociation means after 60 seconds, let x moles of O2 were present. If x moles of O2 are present, then NO2 will be 2x, because ratio between them is 1:2. So if x moles of O2 were formed, then definitely NO2 will be 2x. And we find same ratio here, means 2 N2O5 gives me 2 NO2. So if 2x has been formed here, so 2x must have been decomposed. So left 0.5 minus 2x. Let us find out total moles. Let us add up all. 0.5 minus 2x plus 2x plus x. And we all know total mole will be always equal to total pressure. Remember. So 2x, okay. 0.5 minus 2x plus x. So 2x goes. I am left with 0.5 plus x equal to 0.6. So x will be equal to 0.6 minus 0.5. Value will be 0.1. So we got the value of x is 0.1. What we are focusing on, we are focusing on pressure of N2O5 at t barabar 0, 0.5. I know this value, but I don't know the value of N2O5 at time t. So with the help with value of x, now we can very well find out here. After dissociation, it is 0.5 N2O5 at time t, 0.5 minus 2x, and the value of fx is 1.1. So 0.5 minus 0.2, that gives you value 0.3. N2O5 after dissociation was 0.5 minus 2x. We have got the value of x 0.1. Multiply 0.1 with 2, we get 0.2. Subtract 0.5 minus 0.3, sorry 0.2, I get my value 0.3. Now everything is clear. Original pressure is 0.5, pressure at time t is 0.3. We'll just put up here. So K equals to 2.03 upon T log original pressure upon pressure at time T, 2.03 time 60 seconds, so let it be second only, log original pressure 0.5 and pressure at time T is 0.3. Decimal goes, so I'm left with 1.66. So 2.03 into log 1.66 upon 60. Log 1.66 value is 0.22. So 2.03 into 0.22 divided by 60. Classical value 8.4 into 10 to the power minus 3 second inverse. 8.4 into 10 to the power minus 3 second inverse. So class, this is the way you can solve your numerical on pressure. Our next topic is difference between order and molecularity. Remember class, we are talking about difference between order and molecularity. So class, first order always determined experimentally. Order you will be always determining experimentally. We will be doing a numerical and we will be able to find the order of the reaction with the help of that numerical. But molecularity, it is a theoretical concept. See, in this reaction 2HI giving me H2 plus I2. Since 2 moles of HI were reacting, therefore molecularity is always 2. Order of a reaction may be 0, fractions, positive or negative. Class, molecularity never 0 and never in fractions. So class, these are the two very important things which you must remember about difference between order and molecularity. Now class, we are going to find order of reaction by initial rate method. So see the heading, finding order of reaction by initial rate method. Just now I told you that order of the reaction can be calculated by experimental method only. So we have done one experiment and we have got this following data. I am reading for a reaction, general reaction 3A plus 5B giving me product. Following data were obtained. Experiment number, molar concentration of A, molar concentration of B, rate. In experiment 1, we have taken molar concentration of A 0.1 molar, B 0.1 molar, rate was found to be 3 into 10 to the power minus 5 mole inverse, second inverse. In experiment number 2, we have doubled the amount of A, 0.2, we have kept B as a constant. We got order of the reaction is doubled. In experiment number 3, we have made the concentration of A constant and now we have doubled the concentration of B, but the rate has no effect. Same rate 6 into 10 to the power minus 5. Now the question reads, find number 1 overall order, number 2 rate law expression, number 3 rate constant, and number 4 rate when A is 1 molar and B is 2 molar. So class, let us start how to solve it. So first we'll take up, let order with respect to A equals to X and order with respect to B equals to Y. Then we'll write a general rate law expression, R equal to some constant K, A to the power X, because we have taken order with respect to A is X, and B to the power Y because we have taken order with respect to B is Y. Then class, what I am going to do? I am going to divide experiment number 2 by experiment number 1. Why I am doing so? Because these are the constant value. This will get cut and we will be able to find out the value of X with the help of dividing 2 by 1. So class, R2 by R1, the rate, second rate was 6 into 10 to the power minus 5, R1 3 into 10 to the power minus 5 equals to some constant K, and at second rate concentration of A was 0.2. So I put here 0.2 to the power X because order is with respect to A is X, and Y was 0.1, B was 0.1. So I have written 0.1 to the power Y. This was for R2. Now divide by R1. So again I am going to put the value of R1 here. See, rate is 3 into 10 to the power minus 5. Some constant K. Concentration of A at that time was 0.1 to the power X, and concentration of B again 0.1 to the power Y. So we have got this expression. Now 10 to the power minus 5 goes with 10 to the power minus 5. We are left with here 2. K goes with K. 0.1 to the power Y, 0.1 to the power Y. They also get cancelled. Decimal cancelled. 1 to the power X is 1. So we get here 2 to the power X equals to 2. So 2 to the power X equals to 2. In the next step I can write 2 to the power 1. We use right to equality. If 2 to the power X equals to 2, then we can write 2 to the power 1. That is also equals to 2. So the value of X is 1. Same thing we are going to do in the next step. We are going to divide R3 by R2. R3 by R2. So same value, they will get cancelled and we will be able to find out order with respect to Y. So R3 by R2, some constant K at R3, concentration of A was 0.2, concentration of B was 0.2, so 0.2 to the power X, 0.2 to the power Y, and rate was 6 into 10 to the power minus 5. Then R2, rate was 6 into 10 minus 5, R2 equal to some constant K, molar concentration of A 0.2, so 0.2 to the power X, molar concentration of B 0.1, so 0.1 to the power Y. So class, K goes with K, 0.2 goes with 0.2, this also goes, we get value here 1, decimal gone, so we get here 2 to the power Y equals to 1, so I can write 2 to the power 0, because 2 to the power 0 is also 1, use right to equality, we get the value of Y barabar 0. So this was the main calculation. Now we are going to report our answers. Answer number 1, overall order. Overall order is given by sum of power of concentration terms. So x plus y, x plus y, x we have calculated 1, y have calculated 0. So the value is 1. Answer number 2, rate law expression. R equal to K, A to the power x, B to the power y we used to write. But now we have got the value of x and y. So x is 1 and y is 0. Anything to the power 0 is 1. So R equal to K, A to the power 1. R equal to K, A to the power 1. Similarly, answer number 3, rate constant. We'll take this rate law expression again. R equal to K, A to the power 1. Take any one of the rate here. So R, I am taking the first one. 3 into 10 to the power minus 5 equals to K. Concentration was 0.1 of A, that we can write 10 to the power minus 1. Minus 1 goes with minus 5, left with minus 4. So we get here rate constant value 3 into 10 to the power minus 4, second inverse. And the last step, it has been asked, find the rate when A is 1 molar and B is 2 molar. So we have got the rate expression now for this reaction, R equal to K, A to the power 1. Class, reaction is not dependent on B, so we'll ignore B. So we'll put the value, R we are going to calculate, K we have calculated, A concentration has been given to us as 1, so we'll write here 1. So 3 into 10 minus 4 into 1 will simply give you again 3 into 10 minus 4, but since it's a rate, so unit will be mole liter inverse second inverse. So class, remember unit because marks will be deducted. First order rate kinetics, I have already told you, unit is always time inverse. Here the question was given in second, so we'll write here second inverse. And the last case, since rate is mole liter inverse time inverse, again we'll write unit as mole liter inverse second inverse. Class, with this we complete our chapter called chemical kinetics.